Okay, good morning. So, unfortunately, the projector is not working properly again. Yeah, it would be very good if you can have at least the notes in front of you. So, I have already uploaded them on the Canvas page. Hopefully, you can find it. Yeah, it is better to have it in front of you, but it is not necessary, of course. The topic today is ordinary differential equations. Of course, we just want to look at a very particular case of differential equations. So that is not a course on differential equations. Okay, the first thing I want to... So first of all, you see the word equation. Whenever equation appears in mathematics, it means we have an equality and we are looking for some unknown. Yes? For example, if I write the equation 2x plus 3 equals to 5, this is an equation because it contains an equality sign and then it contains an unknown. In these kinds of equations, I am looking for all possible values for x for which the left-hand side matches with the right-hand side. Okay, so here the answer to this is just a number. Okay, so but in differential equations, the word equation again means I have equality sign there. I am looking for some unknown, but the unknown is not just simply one single number. The unknown is the a whole function. I am looking for an unknown function. Okay, and for this equation, for the unknown function to be differential equation, I should also have at least the derivative of that unknown function involved. Yes. So, for example, this is a differential equation y prime equals to 2x plus 3. So here, this is an equation. I have equality, and this is a differential equation because my unknown function is y. So let me also add, for example, here. So 2y. Okay, so I am looking for a function so that this equality holds. What does it mean? It means that if you give me that function, I replace y with that function, I differentiate that function and construct the left-hand side, it becomes identical to the right-hand side. If I can manage to do that, that function is a solution to this differential equation. Yes? So, for example, if this is a little bit, but by the way, this is the meaning of differential equation. It doesn't mean, by the way, solving a differential equation is easy. Most of the time, we cannot solve differential equations, which comes from science, especially analytically. So we have to do approximations, or we have to do numerical analysis to get the solutions. But for example, if I want to make it a very, very simple differential equation, this is a differential equation. And I am looking for all possible functions y such that when I differentiate them, all of them become equal to x. So as you know, somehow we need integration, but in this topic that we want to talk about this in this module, we really don't need integration that much. So it is a very strange order that they have designed, because usually you need to know integration before doing differential equation. But in this module, the design is in a way that we don't even need integrating at all. Okay, so don't worry about that. But you can guess. Can you guess a function for y? Can you guess that?
X squared over 2.
Yeah, one possible answer is 1/2 x squared. Do you agree? Because if I replace y with this expression, then it becomes 1/2x squared prime equals to the right-hand side. Is it true or false? It is true for all choices of x. So this means that yes, this is a solution to this differential equation. Of course, immediately you can find another solution. Can you give me another solution to the same differential equation?
1/2 x squared plus 1.
Plus, for example, 1. That is also another solution. Yes? Okay, by what we have learned so far, if I ask you, can you tell me all possible solutions to this differential equation? I hope that you can also answer that. Can you see that if I want to find all solutions to this differential equation, which is actually the meaning of solving a differential equation, can you tell me, or just intuitively, what is your answer? I want all possible functions so that when I differentiate those functions, the answer becomes equal to x identically.
Half times x squared,
Yes?
parenthesis, or plus k, like a constant.
Plus a constant c. Let me write it c. Okay, so this one it contains all possible solutions. And then c, usually we call it a free parameter. So there is one single free parameter in this. And then I want to talk about the general solution for you now. The general solution. What do we mean by a general solution? In order to understand the general solution in this context that we are going to talk today, first I need to introduce what do I mean by the order of a differential equation. Okay? Every differential equation has an order. What do I mean by that? The highest derivative that appears, the order of the highest derivative that appears in your differential equation is called the order. So for example, if you look at this very simple differential equation, what is the highest order derivative that appears in your equation? That is only the first order. So if I ask you what is the order of this differential equation, you will tell me the order is 1. Okay? So the highest. So for example, if I write this differential equation for you, I don't know, I'm just randomly writing something. This is the differential equation. I wrote something out of my head. It doesn't mean I can solve it. So solving differential equations is a completely different topic. So that's not very easy. But this is a differential equation. Okay, so I am looking for a function y so that, if possible, when I differentiate it once multiplied by 2, when I differentiate it 2 times multiplied by sine and add them up, it becomes e to power x. Even it is not even, I don't know if there is a solution for this or if we can find it. But this is the differential equation. If I ask you what is the order of this differential equation, you will tell me what is the order?
3?
The order. The order is 2. Because the highest derivative that appears, this is derivative of first order and this is derivative of second order. And the highest order is 2. Okay? So that is called the second order differential equation. That's the meaning of order. And when I say general solution for this module, that is enough to know. When I say I want you to find the general solution, I mean find a solution to the differential equation which contains as many free parameters as the order of the differential equation. So for example here, you already know that this is a solution to this differential equation. We confirm that, and it doesn't matter which c I choose. So c is a free parameter that you can choose arbitrarily, and it will not affect. For all c that you choose, this is an answer to this equation. So c is a free parameter. How many free parameters you see in this solution? 1. What is the order of your differential equation? 1. So the number of free parameters matches with the order of your differential equation. So this solution is called the general solution. So if, I don't know, if we can manage to find the general solution of this equation, how many free parameters you expect to be in your solution? 2, because this is of order 2. So that's the meaning of the order. Okay, so might be it's a good idea if I start reading this text for you, if you have it in front of you, because as I said, the projector is not working today. So let us go through everything quickly, and if you have questions. So definition. An equation that contains an unknown function together with one or more derivatives of that function is called a differential equation. The order of the highest derivative that appears in a differential equation is called the order of the differential equation. Any function that when substituted for the unknown function in the equation turns a given differential equation into an identity is called a solution of the equation. A solution that contains as many free parameters as the order of the differential equation is called its general solution. This is also good to know. The variable representing the unknown function in a differential equation is called the dependent variable. and the variable with respect to which the derivatives are taken is called the independent variable. Okay, so if I want to explain the last item here, so if I tell you here which one is dependent variable, because we have two variables in this equation, one of them is y, the other one is x. Which one is dependent? The one which represents the function is dependent, the other one is called independent. So y is the dependent variable and x is the independent variable. Okay, so for example, if I go back to example 1, I have given you a bunch of differential equations, 4 of them. I just want to go through them very quickly. I want to determine the order of each differential equation, and in each case specify the dependent and independent variables. Can you find a solution to each of these differential equations? This is just warming up. We don't have to learn how to solve these kinds of differential equations. Okay, so let us go to number 1. Y prime is 2x plus 3. What is the order of this differential equation, everyone? 1. Let us go to number 2. What is the order of this differential equation?
2.
2. And the third one?
1.
1. And the fourth one?
2.
Is 2 again. Okay, but let us discuss a little bit about that. So for example, the last one, let me write it here on the board. So it is t to power 3, and then this is the Leibniz notation I am using, and then it is equal to 4t cubed, and then I have 2.
No, it's 4.
Yes, this is 4, thank you, and 2t cubed. Okay? So here you see that this is a differential equation. I have equality sign, I am looking for an unknown function. Because you see the unknown function here is x, I am looking for a function whose second derivative with respect to this variable t fits this equation. So this means that, first of all, because the highest order is 2, so this differential equation is of order 2. And if I ask you what is the independent variable, what is it? Which one is the independent variable? Independent means the function variable.
Oh, it's
X. And what is the independent variable? T.
Independent x, dependent t.
No. Independent t, dependent x.
Okay.
Yes, remember the function, the variable plays the role of your unknown function is always dependent. It depends on t.
Okay.
Okay, can you, for example, see if you can solve this differential equation, or at least you can find one answer? This is not part of your module today, but it is good to warm up a little bit. Can you find a solution for this differential equation? A solution, or the general solution in the ideal case. So how can I solve this problem?
Divide by t cubed.
Yeah, that's a good idea if t is not 0. Okay, so let us assume, I don't want to be very pedantic now, so if assuming that t is not equal to 0, then I can divide everything by t cubed, then I will have the second derivative of my unknown function with respect to variable t. If I divide this by t cubed, it becomes 4t, this becomes 2. Okay, so this means that I am looking for a function which depends on t, and I want to find it in a way that when I take the second derivative of that function, it becomes 4t plus 2. Okay, for example, you know a little bit of integration from your high school, but can you, for example, tell me what happens? If I tell you that this is the second derivative, you can immediately tell me what is the first derivative, yes? I want a function whose derivative is 4t plus 2. So what is that function? Can you guess? A function that you differentiate, it becomes 4t plus 2. 2t squared. Yes, 2t squared. And then
2t.
Plus 2t. And if I want you to find all of them, you put a constant c here, for example. But this is not finished because I want to find x itself. I do this process once more. Okay, so what can I say? If I want to find x as a function of t, I need to ask myself, can you give me a function whose derivative is this? Okay, so it is not hard to guess that that function should be this, yes? Yes, and then probably another constant will be added, yes? Okay, so something like this, okay? But tell me, if I don't write that, if I choose C to be 0, and if I choose D to be 0, this is also one solution to my differential equation. This is usually called a particular solution. Okay? But when I put these two, I see two free parameters in my problem. Yes? And the order of my differential equation is 2. And I know that this is a solution to my differential equation containing two free parameters. So this is the general solution. Okay, is that clear? Okay. So I think we can actually skip more or less so let us actually see that. So for example, example 2, I have written some random differential equations for you here. For example, the first one is a differential equation. What is the order? Can you tell me? Do you have it in front of you or not? Okay, so
Example 2.
yeah, so the example 2, number 1 is of order 2. And for example, let us jump immediately to number 4. So because most of you doesn't have this in front of you. Okay, so what about the order of number 2 or number 4?
3.
It is 3. Can you tell me what is the dependent variable in number 4? Y, and independent variable? T. Okay, so that's very simple. Okay, so let us write the example number 3 on the board. Okay, so I have given you a function. That's something that you need to know. So y is given to you. Y is equal to ax cubed. And then I have it with b over x. And then I have proposed a differential equation, x squared y double prime. And then I have equals to xy prime plus 3y. So this is proposed in the question. A differential equation is also given. We are supposed to show that this is the general solution on this for this differential equation on any interval which does not contain 0, because 0 will be problematic for this fraction. Okay? So this is a very simple and typical question in differential equations. And then moreover, we want to find a solution which fits these two equations as well. So y of 1 is 2, and then y prime of 1 is minus 6. So later I want to fine tune a and b so that these extra conditions are also met. Okay, so this is very easy. Okay? A differential equation is given to you, a solution is also proposed. What you want to show is that to confirm, yes, this is indeed the solution. So what I have to do, I have to calculate y prime and y double prime and put them in this equation to see if this equality holds or not. So simple. So I need y, which I have it. I need y prime, that's my duty to find it, and I need y double prime. Okay, so you can use the quotient rule here, but it is always better to avoid the quotient rule if there is a way to do that. Instead of doing it by the quotient rule, I bring it up so that the differentiation process becomes more smooth. Okay, so now I can differentiate it. So y prime is equal to 3ax squared, minus 1 goes down, so it's minus bx to the power of minus 2. And then y double prime, you see it is very simple if you bring it up. Otherwise, you have to use the quotient rule twice. So this becomes 6ax, and then it becomes 2bx to power 1 unit less. Okay, so now I calculate the left-hand side, for example. The left-hand side is x squared y double prime. This is my y double prime. I multiply it by x squared. If I multiply this by x squared, it becomes 6ax cubed. My plus 2bx to power minus 1. So this is my left-hand side. And I calculate the right-hand side. So the right-hand side is x times y prime. This is my y prime. And then plus 3 times y. This is y itself. So it is ax cubed plus bx to power minus 1. But I have to simplify, so I simplify. So I multiply this x in, and I multiply the 3 in. Yes. And then what happens, this one and that one will be added to 6ax squared. This one is minus, this is plus 3, so it becomes plus 2bx to power minus 1. Yes? And then if I give this number 1 and if I give you this number 2, so by comparing them, so from 1 and 2, you can see that the left hand side is indeed equal to the right hand side. Yes? So, and then I hope that you understand that for any choice of A and B, this analysis works. Because when I was doing this calculation, I didn't even know what A is or what B is. Understandable?
Somewhere there's
Ah,
isn't
yes.
it like x squared and x cubed?
Ah, yes, there should be a
In
mistake.
the right hand side, the second.
This is x squared. So, yes, thank you very
Okay.
much.
Okay, now it's gonna be
Yes, thank you. That's correct. Yes. Okay, but can I call this the general solution to that differential equation?
No.
We know it's a general solution.
No, we know that this is always a solution for any choice on A and B. So how many free parameters are there? 2. What is the order of my differential equation? 2. So you have to write it down. Yes, this is the general solution because first of all, it is a solution and it contains 2 free parameters, as many free parameters as the order of the differential equation. So that's the general solution. Okay, but now if I equip the general solution with extra conditions, so you see that I have 2 free parameters. If I really want to fine-tune both of them, how many conditions I need to know? 2. If the conditions are given at the same point, this is called initial value problem. Okay, so you see that I know y at 1. I know something about y again at 1. Whenever this happens, that condition is called initial value condition. But sometimes might be they give you like this. They give you y of 1 is 2. And they say you y prime of 2 is 7. For example. Then one condition is given at 1. The other condition is given at a different number 2. This is usually called boundary value problem. So that's just the difference between names. So sometimes they just give you a differential equation and they want you to solve it, find the general solution. But sometimes they ask you solve the following initial value problem. What do you expect? You expect a differential equation with some extra conditions. Both of them or all of them are expressed at the same point. But sometimes they ask you solve the following differential equation, solve the following boundary value problem. Okay, what does it mean? It means that you expect to see a differential equation with appropriate number of conditions, but they are expressed in at different points. So that's the difference between boundary and initial value. As far as I see, all the questions in your workshop is initial value problems, so they are being expressed at the same point. Okay, so now if I want to fine-tune it, how should I do that? I want to find, so this is the question. They give you this differential equation, for example, with 2 extra conditions, these 2 conditions, and they ask you to solve the initial value problem. So when you see initial value problem, you should expect something like this. Okay, so what does it mean? It means that somehow, if you learn how to find the solution, you also need to fine-tune the free parameters. So it means that y of 1 is equal to 2. So what does it mean? It means that if I go to y and replace x with 1, the answer is supposed to be 2. So I go to y, I replace x with 1, so this becomes a plus b, the answer is 2. And then I am caring about the other condition, so y prime of 1 should also be minus 6. So it means that if I go to y prime and replace x with 1, which I will get 3a minus b, the answer is minus 6. Okay? And then I don't want to continue because this is simple. You find a and b. When you found them, you put them back into this equation. That becomes this becomes the solution of your initial value problem. Let us do it together very fast. So if I want to solve that, so a becomes minus 1 and b becomes 3. Is that right? Yes. So a is minus 1, b is 3. So this means that the answer that you have to provide is a x cubed. A is minus 1. b over x. So this is the solution, the only solution for the initial value problem. But the whole differential equation, if don't have these conditions, I have infinitely many solutions for any possible choices for A and B. Is that right?
Yeah.
Okay, so I have given you some examples that might be we can skip until example 6. Let me do one of them. So yeah, some of them are actually a little bit lengthy. Also number 6 is a little bit lengthy, but let me just do it for you, okay? Usually you will not receive these kinds of questions in the exam, okay? They will ask you to solve a differential equation. We will talk about that. But let us just do one more example. So example number 6, I have given you a differential equation. So what is that? The second order x dt2, and then I have plus 2dx dt, and then I have plus 2x equals to 0. Okay, so and I'm asking you show that xt equals to a e to power minus t sine t plus b e to power minus t cosine t is the general solution of this differential equation. And then we want to use this to solve this initial value problem. Yes. Okay, so first of all, let us understand that this is indeed a differential equation. I have one equality and I have one unknown function. The unknown function is x, which is my dependent variable, and the independent variable is t. Okay? And the order of the differential equation is 2. And then you see that the proposed solution has 2 free parameters in it. If I can confirm that for any choices of A and B, this relation fits this equation, then it means that I can say that this is indeed the general solution. Okay. So you see, this is a little bit, this is a practice in differentiation rather than differential equation, because the main idea is that this differential equation is given to you. You don't know anything about this. You're supposed to find it yourself. Yeah, but that's not part of this course, okay? But let us see if we can do that. How many derivatives I need? I need x here, which I have it. I need the first derivative. I also need the second derivative. So if I want to do the first derivative, so dx dt. So I have to take the derivative here, but that's a product rule. I have to differentiate here. That's also a product rule. So it becomes a derivative of the first one times the second one and the other way around. So if I do it fast a little bit, I hope that you don't have any problems. The derivative of e to power minus t is minus e to power minus t multiplied by the second function plus the other way around. The derivative of sine is cosine. Yes, this is the derivative of the first part. The second part the same, so it becomes minus b e minus t cosine t minus b e to power minus t sine t. Do you agree with what I have written? I'm just taking the derivative. Each one of them is a product rule. Yes? The derivative of this one multiplied by the second one plus the first one multiplied by the derivative of the second one. And the same idea here. The derivative of this one multiplied by that plus this one multiplied by the derivative. I just did it quickly because this is not the most important part of the lesson today. Okay, so then what should I do? I need another derivative, and every one of them is now a product rule. So you have to be careful not to mess them up. Okay, so the second derivative becomes what? This becomes a e to power minus t sine t minus a e to power minus t cosine t. That is for the first one. For the second one, that is for the second one. For the third one, yes, and then another one I have plus, and finally for the fourth one, yes. So that becomes the derivative of these things. I am going a little bit fast, I know, but this is something very simple. I'm just doing it quickly, okay? And then let me also write x here, yes? So I need 2 of this derivative. So if you don't mind, let me now multiply by 2 to save some time. Yes? Did I make a mistake?
Just to see if I'm following, we are doing that formula when we do like f prime plus g,
F prime g plus
times
f g
g
prime.
plus f times g prime,
Yes, yes.
and we did it twice.
We did it 4 times. One for this, one for this, one for this, one for this, for the next one. But for the first one, you are right. I did it once here, another time here, 2 times. But then I am on this line. I want to differentiate one more.
Okay.
I have to do it 4 more times.
We are doing again.
Yes. Okay. So now the reason I put a 2 there, because I need this combination. I want to save some time. So I just multiplied everything by 2, and I keep the same. And I multiply x by 2. This is x by 2. So I multiplied by 2. So 2x becomes what? 2a e to the power minus t sine t plus 2b e to the power minus t cosine t. I hope that I haven't done any mistakes. If I haven't done, when I add them up, it should be what? It should be what if I am not wrong?
1?
No, it should be?
Whatever the initial thing was.
The differential equation is this one. So I want to add them up. The answer should be 0. So let us see. I hope that I haven't done something wrong, but let us do that. So if I add them, so for example, this one and that one are gone. Is there something with this one? Yes, this one and that one are gone. And then what do I have? This one, and then I have another one, minus 2 of them with 2 gone. Yes. And then, for example, I don't know, this one and that one is gone. They are themselves gone. And this one and that one is 2 plus 2, and that's minus 2. That's also gone. And these 2 are also gone. That's 0. Yes? I mean, this is something you can just go and then do the calculations if you're a little bit confused. But this is very, very simple things. Okay, now the main point, I want to skip example 7 as well. That's a good example. If we have time, I'll come back to it. But now the real module starts from here. So that was just an introduction. For some reason, in this module, they are interested that you know about how to solve linear, homogeneous, second-order differential equations with constant coefficients. Okay, so let me explain what they mean. Okay, if I have a differential equation, what do I mean by it being a linear differential equation of second order? When I say second order, okay, it means that how many derivatives you expect, the maximum derivative should be 2. So let us write the whole possibilities. When I want to have second order derivative, in principle, I might have my function. I might also have the first derivative. But then because I want to be at the second order, it means that the maximum order of the derivative is 2. So it means the functions that are involved are of this type. So in your differential equation, when you say I have a second order differential equation, you have some independent variable that the book and the workshop problems have chosen to be t, not x. So let me also respect the convention there. Instead of x, I am using t, for example, for time. And then y's are all functions of t rather than being functions of x. But when I say second order, in general, I might have y involved, I might have y prime involved, and definitely I will have second order derivative involved. So that is the things. But every one of them might have some coefficients. The coefficients might also be involved with y. For example, I might have sine of, let me make it simple, might be I will have e to power y times y prime plus, I don't know, 2y prime minus sine of y times y equals to a function of t, for example, t squared, for example. This is a differential equation of second order. Okay? It's a second order. But when I want to add another phrase to it, linear, this is important to understand. When I say my differential equation is linear, it means the coefficients of y, y prime, and y second prime are either constants or functions of independent variable, t. Okay, so this is not linear. For example, yes, the coefficient of y prime is a constant, no problems, but the coefficient of y is sine y, which depends on y. We don't want this to happen. It should be either a constant or depends on t. Okay, so it's not linear. If I want to make it linear, for example, I have to take it off. For example, one thing I can write is to write sine t. Okay? So the coefficient of y is a function of my variable t. The coefficient of y prime is a constant, no problems. But still this is not good, because the coefficient of y double prime is a function of y. I want to have it a constant or a function of t. So for example, I can replace it with t itself. So now if I ask you, is this equation a linear equation? You would say yes. Understandable? What is the meaning of being linear? Okay? And there is another word called homogeneous. Okay? Homogeneous is simple. Homogeneous means the right hand side is 0. Okay? So we have the second order linear differential equation, and if it is homogeneous, it is 0. But you don't even study this one, you study simpler than that. You study second order linear homogeneous with constant coefficients. So what does it mean? It means that this is also not allowed, this is a number, this is also a number. So this is called a second order linear homogeneous differential equation with constant coefficients. Is that right? That's the meaning of all those words that you need to know. Okay, but you can, in this module, you need to know how to solve these second order linear homogeneous ones and non-homogeneous ones. When I say non-homogeneous, means the right hand side is a function of t. This is a non-homogeneous linear differential equation. Okay? Is that clear? Okay, so let us just start. So it means that for the time being, I want to follow the convention in the module, so I will choose t as my variable. Okay? Independent variable t, the dependent variable y. Okay? And I write this a y double prime plus b y prime plus c y equals to 0. So what is this? This is second order linear with constant coefficients and homogeneous. So we want to know how to solve this. And the good news is that this is very simple, but you have to remember the formulas. Okay. Let me ask you one question. For example, if I just write this one, I'm just randomly writing one of them for you. I just want to see how do you feel about it. So let me write like this. Okay. If you want to guess one function that has a good chance to fit this equation, what type of function you think about? So is the question clear? Of course, it is not that easy. What I want a function so that when you multiply it by -3 and you differentiate it and multiply it by 2 and differentiate it another time and put this here, it becomes equal to 0 identically. Okay, so what type of function might be a good candidate if I just want to randomly choose a function to see if it works there? Yes?
fx equals 0.
Yeah, 0 is the trivial. Yes, of course 0 is working. If y equals to 0, it works. So, but why 0 is not good? I mean, it's a solution. It's a solution, but usually we are looking not for a solution, we are looking for all, which means the general solution. So y equals to 0 is of course a good question, is a good answer, that's correct, but this is not the general solution. Why? Because it does not contain any free parameters. Yes?
Sum. exponential one.
Exponential function is a good candidate, you know, because if I have an exponential function, let me just write it for you here. Okay, so what happens if I differentiate exponential function once? What is the answer? R goes, so it becomes the function itself, you remember, by the chain rule, and multiply, we learned this yesterday. The derivative of e to power u is e to power u, but multiplied by u prime. So the derivative of this one becomes the function itself, but multiplied by the derivative of Rx, which becomes R. Okay? And then what happens? What happens if I have y double prime? So it is not becoming complicated. You see, the function keeps its form, but it picks up some numbers, some coefficients. So if I take this one more time, it gives me another R. So yes. And let us fine-tune R, if possible, so that this fits this equation. I am not saying it works, but there is a good chance for it, yes? Let us put everything back into this equation. I am looking for a good R for which this works. If I put it back here, what happens? It becomes A. Instead of y double prime, I put r squared e to power rx plus b. Instead of y prime, I put r e to the rx plus c. Instead of y, I put e to the power of rx. And I want to make it equal to 0. My demand is to fine-tune r so that if possible, it becomes 0. But do you think it is possible or not? It is let us see. First of all, am I allowed to divide everything by e to power rx to make life simpler?
Yeah.
Yes, because e to power rx is guaranteed to be not 0. That's an exponential function and it cannot be equal to 0. So when I divide, I am left with a very simple equation. And that is an equation, it's a normal equation. This is not a differential equation anymore. It's an equation for the unknown r I am looking for. It's a quadratic equation, so you have ABC or PQ formula to solve it. Yes? Mm-hmm. This equation is called the characteristic equation.
Why is that?
I will tell you equation because it tells you it tells you the character of this differential equation. You will see the characteristic equation. So you don't need to derive it every time. If you have it in your memory, and if I give you this equation, you can immediately write the characteristic equation. And this is simple. You just put A here, B here, and C here. But then for double prime, you have r squared. For y prime, you have r, and for y, you have nothing. That's the characteristic equation. But you already know, when I have a second degree equation, how many situations might happen? Sometimes it has two solutions. Yes, so if I want to solve that, do you remember the ABC formula? It is minus b plus or minus a square root of b squared minus 4ac divided by 2a. Okay? So if number one, if you don't mind, by the way, this is called discriminant. I show it I have shown it with delta. Yeah. Sometimes we show it with D, capital D. So this means that if delta is positive, how many r's you get?
2.
2. One with positive, one with negative. So you get 2r, r1 and r2. So it means how many solutions I got? Because my solution, my guess, this is the trial solution. That was my trial solution, but that was a good educated guess because it's going to somewhere, yes? So this means that how many solutions I have? I have ER1
ER2
x and I have ER2x. Yes? Okay. But which one I should pick?
Both one.
Okay, so both one means what? Because you know, I am looking for the general solution. If I write this one, that is not wrong, it is a solution. If I pick this one, that is also not wrong because that's a solution. But a solution is not what I want, I am looking for the general solution. The general solution means a solution that contains how many free parameters in this case? Because the order is 2, I need 2 free parameters. This one alone does not have any free parameter because R1 is found. So there is no free parameter here, there is no free parameter there. Okay? But the answer is very simple. You multiply the first one by any constant that you like,
5.
plus multiply the second one with any constant that you like.
8.
Yes? And still this becomes a solution, but this is not trivial. I need to confirm that this is the case. So if I say this one is a solution and this one is a solution and R1 and R2 are different numbers, then my claim for you is that this will be the general solution. Okay? Which I need to confirm. In order to show that this is the general solution, one thing I can prove in general. If I have this type of equations, which are linear, I mean linear is enough, you don't need to even have constant, but let us make life simple. If you give me two solutions y1 and y2, some of you might be able to guess, for example, y1 is a solution, y2 is also a solution. My claim for you is that if you multiply one of your solutions by any number like alpha you want, and multiply the second one with any number beta you want, and add them up, if these two are solutions, this will remain a solution for any choice of alpha and any choice of beta. This is my claim. I haven't proven that yet. Do you understand what is going on? So I'm telling you that if somehow you manage to find two different solutions for this differential equation, let us say one of them is y1, the other one is y2, if you multiply y1 by any number you like, multiply by y2 by any number you like, and then add them up, this is still a solution. Yes, can you see that? It's not hard. Because when you say y1 is a solution, what does it mean? It means it fits the equation. So when you say y1 is a solution, it fits the equation. When you say y2 is a solution, it means it also fits the equation. Do you agree? Now my claim is that this is also a solution. If I want to prove my claim, I have to show that it also fits the equation. So in order to do that, I replace y with this proposed value expression. So I need to know that if I replace that into this equation, it works or not. For any sorry, let me put the prime up there first. I want to convince you that this is also 0. Do you agree? So this is a solution, it means this. This is a solution, it means this. Alpha and beta are arbitrary constants. I constructed this. I am claiming that this is also a solution. To prove my claim, I have to convince you that if I replace it in this equation, it will work. I replaced it, and now I want to show that this works. Okay, that's simple. So you see what happens. This double prime goes here and here. So let me clean it and put it here and here. This prime goes here and here. Okay, and now let me open it up. I multiply this in. This term, and this term will have one alpha in common. I will factor the alpha out. And then this term, which one is that? Yes, all of them have in common. So let me write them down for you. Okay, plus when I multiply this term and that term will have a beta in common. So I factor beta out. From the first one, a y2 double prime is left. From the second one, b y prime 2. And then from the last one, c is left.
CY1 and CY2.
Where was it?
In both brackets, it's CY1 and CY2.
Ah, yes, thank you. Yes, that's correct. But now, what is the answer to this? It is 0. And what is the answer to this? It's also 0. So the full answer is also 0. So remember, this is not only for constant coefficients. If you have any linear homogeneous differential equation, even if the coefficients are not constant, this is always true. And this is usually called a linear combination. Linear combination. So if I want to say it in words, I would say that if you give me two solutions, I guarantee that any linear combination is also a solution. So this is why this part is done. So if I give you this equation, the first thing you do, write the characteristic equation, extremely simple problem. It's a quadratic equation, use ABC formula to solve it. There are three possibilities that can happen. The first possibility is that this number, which is delta, is positive. If it is positive, I will have two different roots. When I have two different roots, it means that I have two individual solutions. But I want a general solution. According to what I told you, if I make this linear combination, it is still a solution. And that is enough. Why? Because now I have my two free parameters that I need. Is that one clear?
Yeah.
Okay, but let us go to see what happens. Okay, so yes, we can have a break for 5 minutes so that I can adjust the camera for the other board. Thank you.